let's check out our problem of the day. Today's problem of the day, how about it? Change the equation. We got 3x minus 4y equals 12 into this creature called slope-intercept form. All right, change the equation 3x minus 4y equals 12 into slope-intercept form. So let's take a look at this. First of all, some of you are going like, well, what is slope-intercept form? And first of all, what kind of form is this? Well, this form is what we call standard form. All right, we've got the x and the y both on the left-hand side. We've got x as a positive coefficient. We got 3 rolling here. And we have some number over here, a constant of some sort on the other side is equals. Now, that's an equation. It is an equation. So what we're going to do, we're going to take that 3x minus 4y equaling to 12. That's our starting point. We always know where we are. Now we got to figure out. And by the way, that means 3 times x, some value of x, minus 4 times some value of y. We're going to be able to get 12. Now, there are a lot of ways. There are many ways that we can make x and y work there to give us 12. For example, I could put, how about it, 0 in for x, and then a negative 3 here. That would give me 0 plus 12 equals 12. That's a lot of hit and miss guessing, all right? What we're going to do is we want to get y by itself so we can nail some x and y values that really will make this a true equation, all right? So let's take a look and see how we do that. First of all, remember I said something in effect, we want to get y by itself. That's what slope-intercept form is. Many times you've heard, those of you taking algebra and pre-algebra, you've heard that y equals mx plus b. Well, until I get y by itself, I have no idea what my slope is from this, all right? I've got to get y by itself. That means the 3x has got to move, and I've got to deal with this minus 4 on the front of the y. So let's do something about it. First things first, let's go as far away from the y as we can. Right there it is, 3x. We will subtract that 3x from the left-hand side. Now, subtraction property of equality dictates that if we do it to the left, we're going to have to do it to the right. So over here, we're going to subtract 3x. Now folks, real word of caution right here. These do not mix. 12 does not have an x on it, so you can't come up with 9x here. You can't say 12 minus 3 and then put an x on it. It doesn't work that way. They're not like terms, so they have to stay separated. However, over here, we're gone. This is gone, all right? The 3x's have moved. We're left with a negative 4y, okay, or a minus 4y. We can't lose that sign. Sometimes when my students are working a problem like this, they say, oh, we got 4y now. No, you don't. You've still got a negative 4 in front of that. You got to play with that. On the other side, wow, I've got negative 3x, and I've got to add 12. Right there we go. If we look at this, we're getting closer, getting closer. What I need to do now is divide through, and why you say, Ernie, why are you going to divide? Well, because this says negative 4 times y. So what I want to do is divide by the negative 4. Don't put a y with it. It's just going to be a negative 4. You're going to leave the y alone. All right, so we're going to divide by the negative 4. But if we divide by negative 4 on the left, we've got to do it to the right. And we've got to do it not only to part of the right, but the whole thing. So we've got to hit both of these. So here we go. We're going to subtract. Nope, we're going to divide, right? Put a negative 4 right there. And we're going to put a negative 4 right here in all places. We've just set up nice little fractions, which mean we're going to divide, all right? So let's see what happens. Those go away. We got y equals 3/4 x. And notice I went positive, because what's a negative 3 divided by negative 4? It goes positive. Negative divided by positive. Negative divided by negative, we'll get that right, is a negative. And by the way, the negative divided by a positive will go negative. Did I just say negative divided by negative is a positive? I hope so. That's what I meant to say. A little tongue-tied here. And let's do a minus 3, because that is a positive divided by a negative. Right there you go. So this is what we call slope-intercept form. The value next to x is the slope, all right? And this little guy out here by itself, the minus 3, is what we call the y-intercept. So you say, what does that mean? Well, when we graph, the y-intercept is going to be our starting point. That's a c, by the way. And that's going to be at 0, negative 3. That's a point, all right? The slope is the direction how we go to get to our next point. The slope in this case, which we use the letter m most of the time, is 3/4, which simply means we're going to rise. The line is rising 3 and running 4. Basically, that's the idea, all right? And it is a rise over run type thing, all right? So every time we go up 3, we're moving also to the right 4. So there's a little bit more of a slant to the right than it is going up, all right? So in that sense, this kind of tells us the steepness of the slope. If we want to get to a perfectly nice diagonal line that's going right up at 45 degrees, that's going to be 1. Anything less than that's going to be a little less. Anything more than that, obviously, will take you a little more than 45 degrees as you're looking at your line. Now, let's tack this in. Let's go to the calculator here and let's see what it looks like, all right? First of all, I got the new equation. We got it. Y equals, and let's all pick a nice pretty line. How about a red line here? We'll put in 3/4. That's 3 divided by 4. Remember, fraction is division, so that's how we write it. We put an x, and then we have that -3 going on. Let's see what it does for us. Enter, and let's graph. Well, there you go. There's a line going right through there. Notice where does it go? Right there, that's the intercept. Notice it's at 0, -3. And if you follow your points, you go up 3, and you go over 4. If I can get it to go over to 4, there we go. 4 right across there. And then you would be able to do it again. Every time you go up 3 and then on over 4, you'll be right back on the line, okay? And you'll be able to get some good points. And that's what the slope-intercept form does for us. Also, it's a great way to graph, but it's also a great way that we can just throw a value for x in and pop out a value of y, all right? We can find any points we need on that line just once we get to that slope-intercept form. So like I said a minute ago, remember we said it was 0 and -3? Was that what I thought when I looked at 3x minus 4y? Well, if I put a 0 in for 3/4 and I subtract 3, guess what I get? That's y equals -3. So that's where we get that 0, -3. So good start with our problem of the day today. I hope you all are hanging with us here.